I represent a Ream Manufacturing. Ream is an HVAC company that was established in 1925, and it's been a company which is, as Mr. Abdulwajid said, we have 6 months of cooling and 6 months of heating. It's one of the unique companies that can provide you with solutions throughout the year. So we specialize in air conditioning as well as water heating. I take care of the water heating side as product. So this is just a slide about our history of what we have done in the past, and why is it important for Ream to be growing and developing in this segment specifically. As you can see, in 1889, we started with an automatic water heater. In fact, it's world's first automatic water heater by Edwin Rood that belongs to Ream Manufacturing Group. And then in 1930s, we started producing steel tanks. And in 1982, we launched a first heat pump water heaters in the world. In between, somewhere here, we also launched solar thermosiphon system. So in our portfolio as Ream Manufacturing, we have more than 80 brands, including including Ream, Rood, Richmond, Solahart, which has been the forefront of thermosiphon water heaters. Now we also acquired General, which is also Wo General, very famous for ACs, and also now the acquisition is ongoing for Atlantic water heaters as well, which will be completed in June. So in 2025, we also launched our hybrid heat pump ranges for 50 hertz and 60 hertz as well. So in between, we also launched a commercial heat pump water heaters as well for this region. However, for our other regions, we were selling for more than 40 years from Australia, which I will take you through in the coming slides. Where are my located? Currently, I'm at home. Fridays I work from home. However, our regional headquarters is in Alberta. Um, we are based there. We have an innovation and learning center where we have all our products installed, which is based in Silicon Oasis. I invite all of you guys to come visit us. We can arrange, touch and feel of the products. There are a lot of ACs, air conditioning, water heaters installed live in our location. We have our factories for package units in DIP, Dubai, as well as we have our innovation center and our office in Saudi Arabia as well, where our team is located for local support. As you might recognize, Ream as one of the pioneering forces in the market for air conditioning and water heating. We have been recognized by climate control awards for the past 5 to 6 years, where we have won several awards for Manufacturer of the Year, VRF of the Year, Standalone DX AC of the Year. For water heaters as well, we have won several awards, and this is thanks to the quality as well as the hard work of the company to achieve that. So in air conditioning, we are dealing with several factories across the world, including UAE, India, China, Thailand, Mexico, USA as well. And in water heating, we are dealing with Egypt, Greece, Italy, Australia, Turkey, Mexico, and US. So we have different portfolio in our product portfolio, which are manufactured in various factories. And in UAE, we are based to check the trends of the market and see which products we can bring from these factories, and then we start promoting it to our customers. Now, let's talk about market trends, why heat pump water heaters is required, what is the need for it, and overall, why is it trending in the market. Now, as you know that a lot of governments have incorporated various strategies to reduce their energy consumption and to move into renewable form of energy. Now, this drive is specifically driven for the case of climate change as well as for reducing the carbon footprint across the world. Now, as you all might be aware, UAE's energy strategy 2050 aims to triple the contribution of renewable energy, by which your Dubai Building Code as well as Barajil regulations across Ras Al Khaimah have adopted the usage of heat pumps and solar systems for water heating. Likewise, all across GCC countries have adopted certain strategies to implement renewable form of energy. So we have two parts for this presentation. First part, I will take you through residential heat pump water heaters. And in the second part, I will take you through commercial heat pump water heaters. As the time is very limited, I might not be able to cover in details a lot of these technology, as heat pump is a very vast subject. But I will do my best to do justice for this seminar, for you to understand simply certain technologies and terminologies, so we can so you can learn better. If I'm not able to make you understand, you can reach out to me anytime, and we can discuss anything that you require. So let's start from the residential heat pump technology. Now, what is a heat pump technology? What is heat pumps, let's say? So we have heard about domestic pumps, water pumps all the time, right? So the function of water is to add kinetic energy and to move from one place, from low pressure to higher pressure. So heat pump is exactly the same. However, in the exception that instead of kinetic energy, we are transferring thermal energy, that too from higher temperature to lower temperature. So the heat is transferred from the higher side to the lower side. And this is why this is called as heat pump technology. Now, how does it work? It starts with four main components that we have. The first part of that is evaporator. Evaporator, I guess you guys are all familiar with air conditioning cycle. If I have to explain to you in a very simple terms, you might have used a refrigerator in your house. The front side where you store your food, that is usually cold, but at the back side, if you touch, then it is usually hot. So basically, heat pump is inversion of refrigerator that is used to heat the water. So where the heat is getting rejected in the fridge, there we are using the water to be heated. Now that gives a great advantage, and what advantage we will discuss in the coming slides. So all these terms, when I explain to you about heat pumps, will be familiar to you. However, think of it as an inversion of air conditioning. So that's an easy way to understand. The process begins with evaporator. Evaporator basically has a refrigerant inside it. That is so the fan gets operated, and the air which is surrounding the evaporator gets passed through the evaporator. Now that's to the surface of the evaporator. Now this air is hot. Let's consider it as hot. That transfers the heat to the refrigerant which is inside the evaporator. Now this refrigerant gas then goes to the compressor. Then when it goes to the compressor, goes to the compressor. Compressor is where the temperature and pressure of the refrigerant increases. This is the heart of the heat pump system. Then this heated gas is passed on to the surface of the tank. This is the tank, as you see, that holds the water inside. This is an aluminum microchannel that is covering or wrapping around the tanks. So when the hot refrigerant enters these condenser microchannel coils, it starts giving the heat, which is at the higher temperature, to the water, which is at the lower side. So here the heat transfer happens. about 5 to 7 degrees, and then this refrigerant loses its state and pressure and temperature, goes back to throttling valve, which uh, makes a gas low temperature and low pressure into a vapor liquid state and goes back to the evaporator. The cycle repeats until the set temperature by the thermostat is reached. So if I set it at 60 degrees and the water enters at 20 degrees, so it will keep heating until it reaches 60 to 65 degrees. So that's how a heat pump cycle works. Now, what is the important benefits of heat pumps? Now, we all have worked with electric water heaters in our apartments. It might not look like this, it might look like a horizontal one, which is inside your false ceiling. So, I kindly ask, if you have not seen a water heater, open your false ceiling. Inside your washroom, you will find your water heaters for a better understanding. This is a central water heaters that is used mostly in villas where electric elements are present. Now, electric elements, the interesting part about electric elements is that when you give 1 kilowatt of, let's say, 1 kilowatt of electrical energy, you are getting 0.93 kilowatt of thermal energy. So, energy can neither be created nor be destroyed, but can be transformed from one phase to the other, one form of energy to the other. So, here, electric to thermal energy is happening. So, when that is the case, you are losing point 0.07 kilowatt of thermal energy due to the losses of your heating element or through the insulation or whatever. Whereas when you have a heat pump water heater, imagine you are giving 1 kilowatt of electrical energy. So the thermal energy that you are going to get is about 4.2 kilowatt, almost 4 times the energy that is given input. So that is the beauty of heat pump water heaters. Now, what it does typically, which I will show you in the coming slides as well, is that if you replace your current electric water heaters with the heat pump water heaters, your bill for heat pump water heaters will be slashed by 75%, which is a major saving for any consumer. So that's the advantage of using a heat pump water heater. What are the different components that you need to take care of? So whenever you look for a heat pump water heaters in a domestic application, your evaporator coils need to be with aluminum fins with hydrophilic coating. Why hydrophilic coating? I think you all have experienced very well in UAE, where we have humidity built up across the evaporators. So due to which the heat transfer could be lower and it could reduce the efficiency. When you have a hydrophilic coating, the heat transfer, usually the moisture that is built up on the evaporator coils can slip easily across and can fall into a drain pan much easier than without having a hydrophilic coating. So this helps, or this aids in the better heat transfer. This is why it's important that you use hydrophilic film coating. Then you also need to look for the tubes inside the evaporator to have inner groove. Now this is required to increase the friction or to increase the surface area and to get the better heat transfer. These are small things, tiny details. However, if you specify or if you ask for these things, then you are going to save a lot of you're going to save a lot of energy over the long run. Then you have compressors. Normally, residential heat pump compressors are rotary type. They are fixed speed. They are highly efficient. They work on different kind of refrigerants. Remanufacturing offers you currently R134A refrigerants for water heating, which is considered as one of the best for hot water heating performances. We are also going to launch later this year an R290 models as well, which will be much more eco-friendly, as well as having a GWP of zero, global warming potential of zero. Then you have condenser. We use aluminum microchannel compared to a coil type condenser, because microchannels we consider as having much better surface area, as well as having much better contact, as they are very flat and they adhere to the outside of the tanks. So it helps us transfer more heat or faster heat from your refrigerant. This is why aluminum microchannel is being offered. Um and also, in case of any refrigerant leakage, there is no contact with the water inside, so it is safe for domestic applications. Then we have electronic expansion valve, which should be automatic type, and that can give you an accurate flow rate as well as reduction of any refrigerant pressure. Refrigerant we use R134A, which has an ODP of 0 and GWP of 1430. This is going to change when we are going to launch R290 version. So GWP will be 0 as well. Now, any water heaters, if you buy just for the technology of heat pumps, it is of no use, because if tanks start leaking, then khalas. I mean, there is no point buying a water heater. You'll have to change the water heater completely. So tanks become one of the most important component of the water heaters. We offer glass-lined steel tanks with non-consumable titanium anodes, which I will explain to you in the coming slides. That are basically this is a special, special recipe developed by Ream in 1950s, so which we use across all our water heaters. So current tank capacities that we have is 180, 280, as well as 400 liters. So three capacities we have: 180, 280, and 400 liters, which are suitable for working pressure of 8 to 10 bar. Now, in this slide, I will explain to you about anodes. Anodes, I think if you have dealt with water heaters, every manufacturer tells you about something called as magnesium anodes, tells about something called as, may not be they're telling about powered anodes, but I will explain to you how the powered anodes work. Before we start on the anodes, it's important to understand what is inside your water heaters. Now, water heaters are usually coming with the glass lining. Glass lining is basically a coating on top of the steel. As we all know, when the water is coming in contact with steel, ferrous will react to the oxides in the water and becomes ferrous oxide. What is ferrous oxide? Rust is the ferrous oxide. So in order to protect your steel tanks, we every manufacturer or most of the manufacturers will either offer you stainless steel 316L or steel with the glass lining. Now, glass lining is the most important factor in protecting your water heaters. But this glass lining has a porous kind of structure. It is not completely like a glass, if you can imagine. This is having certain small microscopic pores. Now, what happens is that when you have certain microscopic pores, the water which is inside the tank start entering these pores, and they come in contact with the steel directly. So in order to protect that steel, we introduce a chemically active element which is more active than steel. Which is that element? Some manufacturers introduce aluminum, some manufacturer introduce something called as magnesium. So it, as you can see in the slide, there is a silver color or a grayish color component, which is a magnesium anode. This is introduced inside the water heater. If after 6 months of installation, you will see that this magnesium anode, which is silver in color, starts turning like this. Why? Because of water quality. Now, water, because this is a consumable part. This is like your brake pad, as I like to say. It's a brake pad. You need to keep changing every 1 year or 2 year, depending on the manufacturer recommendation. So this is a consumable part. So we introduce this inside the water heaters to protect the tanks. Now, this gets consumed and after 2 years, you will see the water heaters have started leaking. And this is a very common phenomena in in most of the parts of UAE, where you might have experienced, you have installed a water heater and within 2 years it has started rusting. When you open the water heaters, you will see there is no magnesium anode at all. So this is a practice that we need to educate people about, especially with magnesium anodes, to at least change it every year or every 2 years. Now, heat pump water heaters, let's say, is an investment by your end user, end client. This is in comparison to a traditional electric water heater, the price is about 2 to 2.5x of your electric water heaters. So you need to protect that investment. So what we did to, in order to protect that investment, we developed powered anodes. Powered anodes are basically titanium anodes. These are non-consumable type. So in this anodes, there is no uh, there is no dissolving of magnesium anodes. It doesn't dissolve like magnesium. So basically, this titanium anode is connected to a DC voltage of 6 volts. DC voltage of 6 volts. This is less than the voltage of your batteries. What it does is, it's every 1 second to 3 second, this this titanium anode gives out a charge to the water. Now what it does is, this is mimicking that I have more positive charges than the tank. So basically this is mimicking your chemically active substance. And what it does is, all the ferrous that is there, all the oxide ions will start then coming towards the titanium anodes. This is controlled by a controller which is inbuilt. Now, by doing this, what it does is, this is protecting your water heaters around the clock. So if you want a non-consumable anode within your water heaters, then go for a titanium anode. This is much better solution than going with traditional magnesium anodes. This does not require any maintenance and it is much easier to maintain. Now, sizing of heat pump water heaters for domestic applications. Now, these are all the fixtures that you have for 2 bedroom, 3 bedroom, 4 bedroom, and 5 bedroom. This is sized as per ASHRAE. So what we believe is that for 2 bedroom apartments, you can go with 180 liters capacity. For 3 bedroom villa, you can go with 280 liters capacity. For 4 bedroom, either you can go with two 180 liters or go with one 400-liter options that we have. And for 5 bedroom, you can also go with one 400 liters or two 280 liters, whichever the client prefers. Now, case study about residential heat pumps. So the first case study is about electric and hybrid heat pumps, which is heat pump technology. For electric water heaters, this is an example where you have, let's say, 300 liters of water inside the water heater with a 3 kilowatt of electric elements. This is a very standard water heaters, electric water heaters that we sell in the market right now. 300 liters with 3 kilowatt. You have this input. However, due to the efficiency and all the losses, you have only 2.95 kilowatt of thermal output. When you put that into the calculation, what you see is that it needs 4.77 hours to heat the full tank one time. And we are assuming that this one tank is enough for the whole day. Okay. Then this, when we get 4.77 hours of operation to heat the water from 20 degrees to 60 degrees, we multiply it with the element that is there, input energy. This will give me total of 14.33 kilowatt hour per day. So this is the total energy that is consumed by an electric water heater of 3 kilowatt to heat from 20 degree to 60 degrees in a day. Now, when I compare that with the heat pump water heater, you will see that my input energy is only 667 watts, or roughly about 700 watts. Okay. Now, with that 700 watts, I am going to get 2.8 kilowatt of thermal energy output. Now, how much is the energy? Same calculations we will copy in the same method that we did in the previously. So the same 2.8 kilowatt from 20 to 60 degrees will take 4.64 hours, slightly better than your even your electric water heaters. When you compare that with the total energy consumed, that will be 4.64 into the energy that you have input, that will give you 3 hours. In the previous slide, we saw it was 14 kilowatt hours. In the heat pump water heaters, it is only 3.1 kilowatt hours. How does it compare with the apple to apple comparison? When you compare that with the kilowatt hour of the heat pumps, you are saving almost 78% of operational cost. Straight up, 78% of the operational cost you will get as a saving. So this will help justify to your customer why you need to go for heat pump water heaters. All the money that customers will save, for example, when you compare that with electric water heaters, your customers are going to save almost about 800 dirhams worth of savings on a single heat pump. If you compare that to the cost of the equipment, it will be within, you will recover all the additional amount that you are paying for a heat pump water heaters within 3 to 4 years at max, where heat pump water heaters are projected to last for more than 10 years due to the presence of your non-powered anodes or powered anodes. Sorry. Then we have case study against solar water heaters. We all know solar water heaters are a very prominent renewable energy in the region. So we have also done that same similar calculations for solar. Now, to calculate the solar energy, we have taken a case study of a city in UAE, which is Dubai. And what we have done is we have got the solar irradiance data, which means that total solar energy that is available throughout the year. Okay. Now, when you look at the electric water, solar water heaters, to heat from 16 degrees to 53 degrees, we are of 300 liters, we need 12.876 kilowatt, because that's the energy that is required using MCP delta T formula. Now, using the solar irradiance data and the formula that we have, efficiency into square root of radiation into area, will give me the energy that I can get, average energy that I can get from the sun. So if you compare to efficiency, I believe this is about 65% for all the solar, most of the solar water heaters. In fact, some solar water heaters are even less. Maximum we have considered as 65%. Absorber area, which is usually 1.8 to 2 square meter of a panel. So in our case, we have considered 300 liters. So there will be two panels, two solar panels. So that will be 3.76 square meters. When you use this formula, multiply all the values, you are going to get 6.8 kilowatt roughly. Now 6.8 kilowatt out of 12.86 will come from solar. Balance should come from your element backup. So that is about 6.108 kilowatt. As we all know, heating elements are 90% efficient. So the final value of electrical backup will be about 6.8 kilowatt. Now, in this example, we have considered a similar delta T from 20 to 60 degrees. And also we have taken the same values as what was there before. So the value is 3.095 kilowatt hours. Value here is 6.78 kilowatt for solar. Now, when you compare apple to apple, Heat pumps will save 50% less running cost. Not only this, it not only saves 50% on the running cost, it also gives peace of mind to all the end users who are using solar water heaters. Why? Because solar water heaters have a problem of overheating in our region, and we know that all most of our customers are complaining or are looking for options that is better than solar. So heat pump provides you a better control, also easy to maintain, as well as saving the operational cost. Now we go back to our second part of the presentation, which is commercial water heating technologies. This is a very vast subject, but I will try my level best to explain to you about the technologies that we offer, as well as some key things that you need to look for whenever you are trying to size the heat pumps. Now, commercial heat pump technologies, there are two modes of heating mainly, which is air to water and water to water. As the name suggests, the energy is transferred from air to water. Energy is transferred from water to water. So that is the two distinctions that we have. Now, the air to water heat pumps that we sell is from Australia. It looks like something like this. There are many manufacturers who are offering such brands, such solutions in the market. In this case, the primary source is air. You have capacities from 20 kilowatt till 250 kilowatt in air to water. In water to water, you have from 70 kilowatt to 280 kilowatt. Now, there are scroll compressors in both of the options. And also, the important part when sizing the air to water heat pump is to look for heat pumps that are suitable for temperatures from 0 degrees till 52 degrees in our region. And for water to water, as they are placed indoors, the temperatures could go up to 35 degrees. Now, the technology of air to water heat pumps I have explained. It's the same concept, but in a bigger scale, much bigger scale. However, water to water, the only change is that instead of an evaporator, you have a heat exchanger. So in this case, the heat exchanger is exchanging the heat from the water. So you have chiller return. Let's say you have a chilled water return at 12 degrees. This will enter the heat pump and this will come out of the heat pump at maybe 5 or 7 degrees. So that will go out back to your chiller, reducing the load on your chiller. So this 12 degrees then gives the energy to the refrigerant, then goes to the compressor, the refrigerant goes to the compressor, then goes through another heat exchanger where you have external tanks connected to this condenser. And then the refrigerant passes through thermostatic expansion valve, then goes back to evaporator, and the cycle repeats. So you will have a pump this side, you will have a pump this side. That's all the difference. It's a very basic, um, very easy to understand, and very easy to work with as well. This is a typical system for an air to water heat pumps. We have done several designs as such. So in case you have any request for sizing the heat pump water heaters, you can reach out to us. We can draft PIDs like this and help you with the sizing selection and go through in detail your design challenges across your projects. So we can do a customized solutions on tanks that can help you fit your needs. In this particular example, we have 3 air-to-water heat pumps that were at roof that are connected to 4 different calorifiers. These calorifiers are about 5,000 liters capacities that have their own YouTube bundle inside the tanks. These YouTube bundles are um, connected to the air-to-water heat pumps via balancing valves. Then we also gave an electric backup for each tank just in case there is any heat pumps going down. If there is any sort of a problem, if the water, sometimes the demand is also quicker in the hotels, so you can use this as a boost to boost the hot water production. And then the rest of the piping we have done based on the site, based on the availability of the data. So this is how a typical air to water commercial system looks like. This is how water to water heat pumps looks like. um, the piping layout remains almost the same, except that we have additional piping on the primary side, which is a chilled water circulation pump gets in the water to our heat pumps and then goes back to the chiller. So this is how a typical water to water heat pumps looks like. You have 4,000 liters tanks powered with 280 liters water to water heat pumps. Yeah. So key data points that you need in your hand before you do the selection is the hot water fixtures, which is the most important thing to calculate based on the different codes that you have, which could be either ASHRAE, DIN, SIPSI. There are even plumbing engineering standards as well. So you need to have hot water fixtures in hand before you go for commercial water heating. You need to know what is the project type. It's a hotel, it's a labor accommodation, or what kind of projects that you're working on. What's the ambient temperature where the units are going to get installed? What's the cold water during winter? That's one of the important key details that we usually normally ask. Do you need an electric backup, or are you only going to rely on your air to water heat pumps? That is also another question. What's the recovery time? Now, this question gets asked by a lot of consultants, and so we normally ask if they have some numbers in mind, but we normally also suggest a couple of things. So, in terms of the recovery time, especially when you're designing hotels, we estimate that there are three peak demands: morning 7 to 8, afternoon 1 to 2, and evening 5 to 6. So if you count the time between each peak demand, you will have 3 hours of gap. So when we size our water heaters, we are sizing as per ASHRAE, that is for peak demand. Now, for peak demand in the morning, let's say 10,000 liters gets over within the morning, then we have 3 hours to recover the whole tanks. So then in the afternoon, when we have another peak, there will be recovery as there is enough hot water. Then again, after 3 hours in the evening, we have enough hot water. So the recovery time can be 2, 3, and 4 hours. We can also go with 6 hours depending on the project and depending on how we size the tank. Uh, so when you go for a faster recovery, which is 2 hours, your heat pump sizes are bigger. When you go for 4 hour recovery, your heat pump sizes are smaller. So based on what is the site requirement, we propose different solutions. We also ask where is the location of the tanks and where is the location of heat pumps. If it's an air to water, we definitely would like to have an heat pumps outside. And if you're not able to give heat pumps outside, then we have to ask you for certain airflow rates and certain things to ensure that our heat pumps will work. Uh, we also ask the question if you need BMS compatibility. Certain clients, they have their own BMS system. They want to look at so many data functions of your heat pumps. So we need to look for our heat pumps. Don't come with BMS, but if we add a customized cards into it, which is supplied by us itself, then we can easily monitor BMS. Um, and also we definitely asks you about footprint, where you're going to install tanks, how much space you're giving me, how much space you have on the roof. If you don't have space on the roof, what are the other options, different options we ask, and if there is any special requirements. So these are some of the key data points that we ask our consultant friends. What's a case study on the commercial heat pumps between electric and heat pumps? This is a project where you have three different modes of heating: electric water heaters, which is 10,000 liters with 115 kilowatt elements, three numbers, so it becomes a total load of 350 kilowatt. Similar heating load, but with an air to water heat pump, you're only consuming 124 kilowatt of total electrical load. Water to water heat pump also, we are at the same level, 124 kilowatt, compared to a connected load of 350 kilowatt. Now, this is a chart which explains kilowatt hour per 10,000 liters for different modes of heating. If you see, the lowest kilowatt hour per 10,000 liter is an air to water heat pump. So, if electric water heater consumes about 372 kilowatt hour to produce 10,000 liters for a hotel, air to water heat pump, similar capacity, takes only 100 kilowatt hours to produce 10,000 liters. That is 73% lower running cost for hotels. And water to water will be 55% lower. Why 55% lower? Why is it not 73%? Because this is a collective figure, average figure throughout the year. During winters, where you are connecting your water to water heat pumps to chillers mainly, and you have a chilled water system. During winters, we have a very partial load. So there is not enough flow rate that we get from the chiller. Now, when that happens, our electric backup are running all the time. This is why you don't have that saving reflecting on your project. This is the very reason why we don't have that saving getting reflected. But still, it saves 55% compared to an electric water heaters. Air to water heat pumps, much better choice, saves even 18% more, which is about 73% lower than electric water heaters. Overall comparison, I'll not go much into details because I have a very limited time. I want to keep some time for the questioning as well, questions as well, so we can just the overview in terms of the maintenance cost, operation cost. Normal electric water heaters are higher. Product life cycle for water heaters are 5 to 7 years only, whereas heat pumps are about 10 to 15 years. And ROI, if you compare that, if you replace an electric water heaters with an air to water, if there is a retrofit job, you will see that within 3 to 5 years you will recover that cost. So which is also one of the important things. Now we go to the boilers for the heat pumps. Boilers against the heat pumps. Now, when you compare a boiler against a air to water heat pump, efficiency point of view, your boilers are only 90 to 95% efficient. If the condensing boilers are about 100 to 103% efficient, uh, but again, these are the maximum you can get out of boilers is about 100 to 103% only. Whereas in heat pumps, you can get about 400 to 500% of efficiency or COP. Now, people who have dealt with boilers, they know the pain of designing the chimneys, designing the gas storage. That calls with all your architects asking for an access, asking for a space to design the chimneys. I know we all know that pain that the engineers have to go through. So that kind of challenge is not there with the heat pump. So you have a heat pump that can be installed outdoor, and if you want to install it indoor, you can use water to water as well. Initial cost almost same. In fact, boilers are slightly higher than the heat pumps, so it doesn't make a calculated decision for the end user to select go with the boilers. Operational cost, what we have seen, what we have done the calculations, what we have seen is that air to water heat pumps 56% less than the gas boilers. Even though gas is abundantly available in our region, however, the cost of gas is not as cheap as it is look like. If you compare that with the energy that we consume in the air to water heat pumps, that is 56% less. So you're going to save, and that's when we are talking about hotels, that's a huge savings, and that will also aid in the better budgets across the hotels. Maintenance cost, boilers, of course, they are heavily maintained across the hotels, as you know, whereas heat pumps are much simpler, plug and play systems, very low downtime compared to heat pumps, so lower maintenance cost. This is our overall product portfolio that we sell in the region across Ream, Rood, Richmond. Um, so you can go through it. We do sell solar, we do sell heat pumps, we do sell electric water heaters, heat pump water heaters. If you have any concerns relating to this, you can reach out to us and we can definitely help you. Now, the important part, questions. If you have any questions, feel free to ask.
Thank you very much, Mohammed Zishan, for a very informative presentation. And I think this kind of webinars mostly, not uh, held in very frequently. And I hope all the members have enjoyed on it. And I think we have to take as much as benefit of all these things, because you have given a good product knowledge as well as the designing philosophy, and also the alternatives as a heat pumps, what we can do. Gentlemen, any questions are there? Please, you can ask the questions. There was one gentleman who is asking for an Excel sheet. No more questions.
Good evening, gentlemen.
Good evening.
Good evening.
Yes, can you put some light on the free cooling we are getting by using these air source heat pump?
Uh, Definitely. So the cooling of from the air to water heat pumps is a byproduct of heating, but it's not its main purpose. So you are going to get from your ambient air about -3 to -5 degrees. So let's say your ambient was 40, the cold air that goes out of the heat pump will be between 3 to 5 degrees.
That's great. That can be utilized to throw toward the condensing units if available. That saves of energy also, right? Thank you so much.
Yes. Now all the webinar points are also available. All the webinar presentation will be available in our YouTube, and the link of this webinar will be posted in the uh, website. So anybody who wishes to revisit the webinar, they can visit on it. And as I have informed in the beginning of the webinar, that we are going to very shortly launch the AI chatbot for our website, where the MAP engineers community doesn't need to struggle much. Put their questions to the chatbot, and the chatbot will find out you the answer through our library, and you will have the answer on at the same time. So in the next stage, we are also launching the chatbot directly WhatsApp group. So this is the second stage we are going to do it. So wait for the chatbot, and also I'm going to announce for the next webinar. The topic will be, just hold on, what's the topic we have selected? Yeah. We have the next topic will be arc mitigation and thermal monitoring solutions in LV switchboard. This is an electrical related webinar. The subject is arc mitigation and thermal monitoring solutions in LV switchboard. So this will be presented by Mr. Srinivas, who has been our long-term friend, and he is now working with Eaton, and a very knowledgeable guy. He has been with me for so many projects on design. He has helped us in designing the projects and developing the specifications and the latest industry practices, IEC codes, and everything. So we will take a benefit out of it in our next webinar, which will be held after Ramadan. Ramadan, we don't want to make webinars because people will also always be, also will be, engaged in their prayers and everything. We will have short times. We don't want to disturb you. Enjoy the Ramadan, pray for everybody, and I think it's the time to close the webinar. And anybody has still questions, still welcome. Otherwise, you can also post the questions later to Muhammad Hisham. Thank you for the admin team who are always working tirelessly to get this webinar successful. So they are the real backbone for us who have been doing a lot on the background to make this webinar happen.
Thank you, guys. Wonderful job. Thank you so much for having me. I hope the webinar was helpful.
Yeah. Thank you, Zishan. Thank you. So,
Salam.